Hello students, this is Professor Sagar Pirche and I welcome you all for the online class of analog and digital electronics. So in this video, we are going to study and understand what do you mean by canonical mean term form and canonical max term form. So let us first discuss on the canonical mean term form. So what is canonical mean term form? Mean terms are basically the product terms where all the variables appear once either in complemented or in an uncomplemented form. So what do you mean by mean terms? Mean terms are the product terms where all the variables that appear in the expression either are in complemented or in an uncomplemented form. For example, if you considered a function, a Boolean function of three variables, let us say these three variables are a, b and c. Some of the possible mean terms that can be produced from these three variables are a, b, c, that is this one, a, b, c. Second one is a bar, b, c. The third possible mean term is a, b bar, c, and the fourth possible mean term is a, b, c bar, and so on. So these are the three variables or possible mean terms that are coming out from the variable a, b, c. So the terms, if you consider, such as a, b bar, or you say the term as c or b, c bar, cannot be called as mean terms. The reason behind that is the variables, all the variables, that is the variable a, comma b and c should appear in a product term. So if either of the variable is not present in a given product term, such term we cannot call it as a mean term. Okay, so in this example, if you see the term a variable c is missing. So there is a, there is b in a complemented form, but there is a term c which is missing. So this product term a, b bar cannot be considered as a mean term for three variables. Similarly, the next term, that is c, where the other variables a and b are missing, cannot be considered as a mean term. The third example, if you see here, b, c bar, there is a one variable a which is missing. So this product term b, c bar also cannot be called as a mean term. So if you look into an example of a canonical mean term expression, the expression should be represented in such way. If you see here, for a given Boolean function with three variables a, b and c, you see that each product term that is a part of this expression contains all the variables, that is a bar, b, c, second product term a, b, c bar, the third product term a bar, b bar, c, and the fourth product term a, b bar, c. If you see in this Boolean expression, all the three variables a, b, c are present either in a complemented or an uncomplemented form. So such expression or terms present in the expression are called as mean terms. So a bar b c, a b c bar, a bar b bar c and a b bar c, these four terms which are present in this expression are called as the mean terms for the given Boolean function a, b, c. If we consider the second example, if we consider this second example where we have four variables w, x, y and z, you can see w bar, x, y bar, z, the first term, and the second term w, x bar, y, z. These two terms have all the four variables coming either in complemented or an uncomplemented form. So this Boolean function can also be called as a canonical mean term expression. Okay. Now the third example, if you see the Boolean function a, comma b has two variables. The expression also contains two variables a b bar plus ab. So these two terms are two variables are present in the given product term. So this is called as a mean term canonical form. So a b bar and ab are the mean terms, and we call this expression as a canonical mean term expression. So the canonical mean term expression can be written directly from the truth table. Okay, so we can look at the truth table and directly we can represent the minimum expression from the truth table. How? Let us see. So consider a truth table here for a function of two variables. So we have a Boolean function of two variables. Those two variables are a and b. Okay, and the Boolean function which produces the output f. Okay, so for 0 0 we have represented as a bar b bar. The Boolean function is representing as 0 0 1, that is 0 means a bar and 1 is represented as b. There is no bar here. Okay, so it is 0. For the third row you can see a is 1 and b is 0. The function is producing a high output. Similarly for 1 1 the function is producing the high output. So the expressions for the third row are a b bar because b is 0 here, and this is ab because both a and b are 1 1. So if we observe from the truth table where a is equal to 1, this one, where a is equal to 1 and b is equal to 0, and for the fourth row where a is equal to 1 and b is also equal to 1, the function f evaluates to 1. So in a given truth table, if the function for that particular row evaluates to 1, the product terms, that is a b bar and ab, okay, who have assigned a value 1 will be a part of the Boolean expression. So because we have a value 1 representing in this function f, okay, so which is evaluating to 1, these two product terms a b bar and ab are going to be a part of our Boolean function. So the Boolean expression written directly from the truth table is f of a comma b, because we have two variables a and b, is equal to a b bar. Why a b bar? Because the function is evaluating to 1. If here it was 0, then we wouldn't have considered a b bar for our final Boolean expression. And then the second product term that is a part of this Boolean function is ab. Why ab? Because the function, again, this is evaluating to 1. Getting? Suppose instead of 0, here if I had a 1, okay, if I had a 1, for 0 0 the function was evaluating as 1, for 0 1 it is 0, 1 0 it is 1, and 1 1 also it is 1. Then apart from these two terms a b bar plus ab, we would have another term as plus a bar b bar. So the function that would have evaluated f of a comma b, okay, a comma b is equal to a bar b bar plus a b bar plus a b. So you can see a bar b bar, why we had added to this expression, because we have taken as 0 0 as 1. So we are part of this. Suppose this was evaluating to 0, then this expression a b bar plus ab was the final Boolean expression which has been directly taken from the truth table, and these two terms are called as the canonical mean term form, or we also call it as the canonical sum of product form, or the other name for such Boolean expression is the canonical sum of product form. Fine. Hope you have understood how to get the mean terms from the given truth table. Okay, the function which evaluates to 1, such terms will be considered for the Boolean expression, and those terms are called as the canonical mean term form, or the canonical sum of product form, or we call it as the canonical sum of product form. Fine. Okay. Now let us move on to the notation that we are going to represent the mean term. So here we have a sigma notation, we call it as a summation notation. The summation notation is used to simplify writing functions in canonical mean term form. Okay, so what do you mean by simplifying the writing function? We'll see with an example. So basically you remember that whenever we are representing a mean term, or whenever we are looking a Boolean function with a mean term, if there is a symbol as summation, we should take it as a mean term. Okay, so basically mean terms are represented by the rows numbers for the function that evaluates to 1. In the previous example you have seen. So mean terms are represented by the row number for the function that evaluates to 1. So this is how we simplify the writing functions. So in this example, if you see, we have given a row number to in this particular table, truth table. Okay, we have a Boolean function for 3 variables x, y and z, and the function f evaluates to either 0 or 1, and the terms representing the variables x, y and z, the values. So as the first row 0 represents 0 0 0, that is x is 0, y is 0 and z is 0, the function is also evaluating to 0. So here, as x, y and z are 0 0 0, we write it as x bar, y bar and z bar. The first row, that is the first row, represents 0 0 1. So x is 0, y is 0 and z is 1. The function is evaluating to 0. So as x is 0, we are representing it as x bar, y is 0, we are representing as y bar, and as z is 1, we represent it as z only. So there is no bar over. So a complement is always represented as y bar, there is a bar over it, and if there is an uncomplemented form, that is 1, we call it as a z1. In the second row, that is the third row, which is represented by row number 2, it is 0 1 0 and the function is evaluating to 1. So whenever a function is evaluating to 1, the terms are going to be a part of the Boolean function. So x bar, y, z bar. So here you can see in the bottom, that is x bar, y, z bar is going to be a part of the function. Similarly, we have row number 3 and row number 5, which are where the function is evaluating to 1, are having the variables terms as a part of a expression, Boolean function expression. So the compactly notations that we can use instead of representing such expression is directly, instead of writing these terms, that is x bar, y, z, x bar, y, z bar, x, y bar, x, y bar, z, these three terms which where the function is evaluating to 1, I will directly, instead of writing these terms, I represent their rows. So here you can see 2, 3 and 5. 2 is the row number where the function is evaluating to 1, and x bar, y, z bar is a part of my Boolean function. So instead of writing these terms, I can directly represent the row for that particular term where the function is evaluating to 1. So this simplifies my writing function. This simplifies my writing function. Instead of writing such a lengthy Boolean function with all the terms representing in a Boolean expression where the function is evaluating to 1, I can simplify this function by writing the row numbers for the function which is evaluating to 1 with a symbol summation. So this sigma symbol, that is a summation symbol, is representing the mean terms. So if you find such function coming, it is, and there is a summation symbol, we term this function as a mean term function, that is in the sum of product canonical mean term form. Okay, so hope you have understood with the canonical mean term form what exactly it is, what do you mean by mean term, and how do we simplify the writing functions in a canonical mean term form using the summation notation. Fine. So the next part that we are going to understand is the canonical Maxterm form. So we have two forms. One is the mean term form and another one is the Maxterm form. So already we have understood what is the mean term form. Let us understand what do you mean by the Maxterm form. So Maxterms are terms where all the variables appear once either in complemented or in an uncomplemented form. So the definition almost remains the same what we have for the mean term. Instead of mean term, we are going to write the max term. So the max terms are where all the variables appear once either in complemented or an uncomplemented form. So a Boolean function uh, with having all the variables represented in that term either in a complemented or an uncomplemented form are called as a max term. So for example, so the possible max term for a function of three variable. So function of three variables are a plus b plus c, comma a plus b plus c, and so on. Here I can write it as like this: a plus b plus c or a plus b bar c. Okay, and so on. So these two terms are called as the max term. It is the product of sum term. Okay, understand it. So the expression constructed using such max terms, the expression which is being constructed using such max terms are said to be in the canonical maxterm form or the canonical product of some form, or we also call it as a canonical sum of product of some form, or that is canonical POS form. Okay, so product of some form are representing the max term, and sum of product form is going to represent the mean term. So while expressing a function in a canonical max term form, we look out for rows which the function is going to evaluate to 0 rather than 1. So here there is a slight change. Now we have to see the function which is evaluating to 0 in the max term, whereas in the mean term we used to see the function which is evaluating to 1. So the function which is evaluating to 0 will be a part of the max term canonical form in the canonical max term form, whereas in the previous term that we have studied, the mean term, that is the function f which is evaluating to 1 was considered for the part of the Boolean function. Now here in the max term, the function which is evaluating to 0, the function which evaluates to 0 will be, such terms will be considered as a part of the Boolean function. Okay, let us take an example and understand how do we represent the max term uh, from the truth table. So writing the canonical max term expression from the given function. Okay, let us have this truth table. You can see we have three variables a, b and c, and there is a function which is either evaluating to 0 or 1. Okay, now we have this row 0, 1, 2, 3, 4, 5, 6 and 7 being represented. Okay, so the first row is 0, 0, 0. So a is 0, b is 0 and c is 0. The function is evaluating to 0, that is a plus b plus c. So now if you look here, Even though A is 0, we are not representing it as A bar. Okay, so here in the max term 0 is represented as an uncomplemented variable, is represented as uncomplemented form. If here in the second row, that is the second row, that is row number 1, if you consider row number 1, if you consider C is 1, whereas A and B are 0 0. So here A is represented as an uncomplemented form, B is also represented as uncomplemented, whereas C is going to be represented as an complemented form. Why? Because of 1. So this is just an opposite of your mean term, where in mean term 0 was represented in a complemented form and 1 was represented in an uncomplemented form. In the max term we represent 0 as an uncomplemented and 1 as an complemented form. So you can look here, this is a product of sum form, just remember that. So in row number 2, that is row 3 number 2, we have A is 0, B as 1 and C as 0. So 0 1 0, the function is evaluating to 0. So the term we are representing as A plus B bar. Why B bar? Because this is representing 1. Okay, this is representing 1. Similarly, row number 3. Okay, now if you see the numbers which I have highlighted, the row numbers which I have highlighted as in red color, that is 0 2 3 5 and 7, where the function is evaluating to 0. Okay, now those rows will be a part of my function. Okay, so the max term corresponding to row 0, that is this one, for which the function evaluates to 0, is A plus B plus C. Observe that for A is equal to B is equal to C is equal to 0, ABC evaluates to 0. Similarly, for row 2, the max term will be A plus B bar plus C, which evaluates to 0 for A equal to 0, B equal to 1 and C equal to 0. The canonical maxterm expression can now be written by collecting all the terms from which the function is evaluating to 0. So here we can see we can represent all these functions. Now it is a which form? It is the product of sum form. It is a product of sum form. Okay, so all these terms which are in a Boolean function are coming out because the function has evaluated to 0. Okay, so this is how we represent the canonical maxterm form. Okay, so the function which evaluates to 0 in the max term are considered as a max term, and those terms will be a part of our Boolean function, canonical maxterm expression. Now let us check what is the notation that is being used to represent the max term. So here for the max term, the pi is the notation that is used to simplify writing in the canonical max term form. So the max terms are represented by the pi symbol along with the row numbers for which the function evaluates to 0 in parenthesis. So if you consider the mean term, we use the summation mark symbol where the function evaluates to 1. Here in the max term we use the pi notation for which the function evaluates to 0. So considering the previous example, here you can see, so here 0 0 0, this is, sorry, I have forgot to write here, a plus x plus y plus z. So this is x plus y plus, as we have 1 here, this is z bar. So this is x plus y bar plus z. In this row number 3, it is x plus, as y and z are 1 1, it is y bar plus z bar. Okay, and then for the fourth row 1 0 0, where x is 1, y is 0 and z is 0. This is x is 1 means x bar plus y plus z. So in the fifth row it is 1 0 1, that is x bar plus y plus z bar. And in the sixth row, row number 6, 1 1 0, 1 is x bar plus y bar plus z. And row number 7, where x, y and z all are 1, it is x bar plus y bar plus z bar, where the function is evaluating to 0. Now you can see here row number 1, if you look here, row number 1, okay, the function is evaluating to 0. So this will be a part of my canonical maxterm function. So 1 is going to be here, 1 is going to be a part of my function. Next we have row number 5, where the function is getting evaluated to 0. So 5 is going to be the part of my canonical maxterm form. And the last row, that is 7, which is again where the function is evaluating to 0, is part of my canonical maxterm form. So this is how we simplify the writing in canonical maxterm form instead of writing all the terms in a given function. Okay, hope you have understood how to represent the mean term and the max term from the given truth table. So mean terms are the sum of product form, as the max terms are the product of sum form. So mean terms where the function is evaluated to 1, those terms will be a part of my function, and we call such function as a canonical mean term form function. A function which evaluates to 0 will be a part of my maxterm canonical form, and those rows numbers will be a part of my maxterm expression. So mean term is represented with the symbol summation, whereas the max term is represented using the symbol pi. So hope you have understood the difference between the canonical mean term form and the canonical max term form. So hope this video clears the difference between the max term and the mean term, and what are mean term, what are the max term, what is the symbol used to represent mean term, and what is the symbol that is used to represent the max term. Okay, so this is all about the video. In the next class we will study and understand how to convert a given expression in a standard SOP or a POS form. Suppose expression is not in a standard SOP form, or if a given expression is not in a standard product of sum form, then how to convert, or what are the steps to convert expression which is not in a standard form into a standard SOP or a standard POS form. That is what we are going to see in your next video lecture. Thank you for watching this video. Have a nice day.